All right, number 6, multiplying radical expressions. Multiplying radical expressions. Basically, what you do is you multiply outside, and he means the numbers outside, together and out in front of the radical. Multiply insides. So multiply the insides together. Rewrite. And then I'm going to say, then do number 5 as needed. I don't want to write the whole thing out again. If you have to simplify, then you have to simplify. Okay? You may or may not have to. It just depends. Okay? So you multiply the outsides, you multiply the insides, rewrite, and then do number 5 as needed. So let's look at 6a. Negative 2 radical 10 times 3 radical 5. So the outsides mean that I'm going to take negative 2 times positive 3. So what's that? Negative 6. Now I put my radical sign and I multiply the insides. 10 times 5, 50. So negative 6 radical 50. But here's the deal. We have to do number 5 as needed. Can radical 50 be reduced? Are there any perfect square factors in 50, Jordan? Huh? Not 49. You got to come up with a factor of 50 that's a perfect square. 25. So what you're going to do with this is you're going to say negative 6 radical, and then for 50 you're going to say 25 times 2. Everybody good with that? So I've got negative 6 that I've got out here and I'm multiplying. What would I bring square root of 25 out as? 5. And the 2 would stay inside. I'm still not done. Because when you bring that 5 out, it's got to be multiplied with whatever's out there. There's a negative 6 out there. So it would be negative 30 radical 2. Questions about that? How we arrived all the way down there. So you multiply everything together, and once you get it multiplied together, you look and see if there's any perfect squares that need to come out of that radical sign, because it's not simplified until all perfect squares are out of the radical. Yes?
What did you do to get negative 30?
I had negative 6 outside here, and when we brought the 25 out as 5, this is a multiplication. So you have to take negative 6 times the 5 when you bring it out. That's where you get your negative 30. Okay, anybody else? All right, so B, a lot more complicated. It's got 2x radical 3x times negative x squared radical 6x cubed. So I've got to take 2x times negative x squared. Okay, well, 2 times a negative 1 would be negative 2. What's x times x squared? X cubed. That's multiplying the outsides together. Let's multiply the insides together. I've got 3x and 6x cubed. So take 3 times 6, 18. And x times x cubed, what's that? X to the 4th. All right, so now I've got it multiplied together. We got to check out the inside. So negative 2x cubed, but let's look at this part inside. Does 18 have any perfect square factors? 9 times 2. X to the 4th, perfect square or not? Yes. So now we got to think about what's coming out, what's staying in, and then multiply the stuff outside together. So I've got negative 2x cubed already out there. And I'm going to multiply it with whatever I'm bringing out. So the 9, it comes out as a what? 3. All right, what about that 2? Has to stay in. What about the x to the 4th? Comes out as what? x to the second. Okay, good. So really all that's left under the radical sign is a 2. And now this stuff outside, we've got to multiply it together. Negative 2 times 3, negative 6. And x to the third times x to the second, what would that end up with? X to the fifth. Negative 6, x to the fifth times radical 2. Okay, questions about that? You'll get the hang of this. It's just new stuff. Okay? Anybody still writing the red? All right. Number 7. Number 7. Okay, so we're doing more with radicals. That's kind of keeping with the same theme here. Number 7 says combine radical expressions. Combine radical expressions. All right, here's the thing. Simplify radical if possible. If numbers in radical are the same, combine numbers outside. Okay, so basically radicals are the same as finding like terms with variables. You know how you can only combine x's with x's and y's with y's and x squareds with x squareds? Same thing is true with radicals. You can only combine radical 2's with radical 2's and radical 5's with radical 5's and so on. So that's what you're looking for. If they are different, they can't be combined, just like you can't combine an x and a y, and you just leave that problem as one long problem or expression. So in 7a, 6 radical 2 plus 10 radical 2, that just so happens that the radicals are the same. So what you do, combine the numbers outside, so it says 6 plus 10, 16, and then you leave the radical the same, just like you would with your variables. That one is 16 radical 2. All right, so B, 7 radical 3 minus 2 radical 12. So it says simplify radical if possible. Well, in this case, it is possible because 2 radical 12, I think I can find a perfect square in there. So what I'm going to do is I'm going to leave 7 radical 3, but this 2 radical 12, I'm going to look at the 12. Is there a perfect square factor in 12? What is it? Yeah, a 4, so that makes it 4 times 3. So my 7 radical 3 is not going to change because there's no perfect square in 3. 3's prime. Now, the 4 will come out as a what? A 2. There's already a 2 out there. So 2 times the 2 I bring out would make it what? 4. This is actually 4 radical 3. Anybody unsure of how I did that? All right, so I've got now 7 radical 3 minus 4 radical 3. They do have the same radical number. So now I just have to take 7 minus 4, and I have 3 radical 3. Okay, questions about that? Anybody still writing the red? Okay, let's look at number 8. Number 8 is solving radical equations. And we have already done this, I think. or a little bit of it. Here's what his description is. It's real technical. You ready? Get, and he's got square root of stuff. Okay? You like that? Get square root of stuff by itself. Okay? Square both sides. Then solve for x. I could swear we've already done this. Did we already do this? Uh-uh. All right, so to this on A, the square root is already by itself. So square both sides means you're going to do this. You're going to square this side, and you're going to square this side. When you square the left, the square and the square root are inverse operations. They cancel each other out. So the left is now 2x plus 3. And on the right, 5 squared is 25. Okay, hold on just a minute. If you had, let me ask you this. If you had 3 squared, what would you have?
9.
And then what's the square root of 9? You see how squaring and square rooting are inverse operations. They always get you back to where you started, 3 and 3. So squaring a square root just takes the square root away. Okay, let's go with this. Square root of 3 times square root of 3. This is a side note, so you don't have to write this. Square root of 3 times square root of 3. You multiply what's inside. What is that? Square root of? What's square root of 9? Isn't this the same as this? Okay, do you believe me yet? Okay, squaring a square root, they're opposite operations. They delete each other. They take them away. So whatever's in the radical sign comes out then. When you square a square root, whatever's inside comes out. Okay, so 2x plus 3 equals 25. Now you should be good to go. Subtract 3 and divide by 2. X equals 11. Alrighty. Next one, B. This one, you've got to get the square root stuff by itself. So, it's similar to when we had absolute value equations and we had to get that by itself. So what would be the first thing you think you're going to do here to get the square root by itself? Plus 7. You always do the adding and subtracting first. So 3 times the radical of x plus 4 equals 15. Divide by 3. Radical x plus 4 equals 5. Okay, now we got that square root stuff by itself. Square both sides. All right, so we square both sides. On the left, we would get x plus 4. On the right, 25. Then you have to solve, subtract 4 from both sides. X equals 21.